Assalamu alaikum wa rahmatullahi wa barakatuh, my dear sons and daughters. Inshallah ta'ala, we'll continue our discussion about the hyperbolic and inverse hyperbolic functions. Bifadlillahi ta'ala, last lecture we discussed the inverse hyperbolic functions. If you remember, we'll make a fast review. We studied the functions y equals sine minus 1x, y equals sine minus 1x, cosine minus 1x, tanh minus 1x, and cosec minus 1x, sec minus 1x, cotang minus 1x. Let us remember these first three ones and enter the other third ones. If you remember, the sine minus 1 has its curve like this, where y equals x, or the 45-degree line is tangent for this function at the origin. As you see, its domain and range from minus infinity to infinity. It is an odd function. It has no periodicity, and we found its derivatives in the form y dash equals 1 over 1 plus x squared. Cosine minus 1, if you remember, it was like this. This one 0. Its domain from 1 included up to infinity not included, and its range from 0 to infinity. It is neither odd neither even, and has no periodicity. Its derivative was y dash equals 1 over x squared minus 1. As you see, x must be greater than 1. And the tanh minus 1 function was like this. It has two vertical asymptotes at x equals 1 and x equals minus 1, and its graph was like this. As you see, its domain from minus 1 to 1, its range from minus infinity to infinity. It is an odd function, has no periodicity, and its derivative obtained as y dash equals 1 over 1 minus x squared, keeping in mind that modulus x less than 1. Also, we studied y equals cosec minus 1x. It is not the reciprocal of sine minus 1. Cosec x is the reciprocal of sine x. Sec x is the reciprocal of cosine x. Cotang x is the reciprocal of tanh x. But in case of the inverse functions, no, this is not. A few minutes later, inshallah, we'll find a relation between cosec minus 1 and sine minus 1, between sec minus 1 and cosine minus 1, between cotang minus 1 and tanh minus 1, inshallah ta'ala. Also, sec minus 1 x, and finally cotang minus 1x. If you remember, the curve of cosec minus 1 was in this form. It has the two axes, coordinate axes, as for the x-axis is a horizontal asymptote, and the y-axis a vertical asymptote. This is y equals 0, this is x equals 0. As you see, its domain from x equals minus infinity to x equals infinity, and 0 is not included, and also its range from minus infinity to infinity, and 0 is not included. While sec minus 1, also this is an odd function and has no periodicity. Its derivative, if you remember, was y dash equals minus 1 over x times 1 plus x squared. Okay, here sec minus 1 it has the curve in this form. Has the y-axis as a vertical asymptote. Its domain from 0 to 1, 0 not included, 1 is included, and its range from 0 to infinity, 0 is included, and as you see, it has no symmetry. it is non-periodic normally, only the 6 functions sine, cosine, tan, cotan, sec, cosec, and its derivative was in the form y dash equals minus 1 over x square root 1 minus x squared. Cotangent minus 1. The curve helps you too much in remembering the derivative. You may be misleading. It is 1 minus x squared or x squared minus 1. From the graph, as you see, x must be less than 1. So it will be 1 minus x squared if not, and not x squared minus 1. Because if you wrote x squared minus 1, this will be imaginary under the root, because all the values of x are less than 1. So x squared minus 1 under the root will be an imaginary value. So it is 1 minus x squared and not x squared minus 1. In case of cotangent minus 1, if you remember, its curve was like this. The x-axis is a horizontal asymptote, and the two lines x equals 1 and x minus 1 equals minus 1 are two vertical asymptotes. As you see, its domain from minus infinity to infinity, except the interval from minus 1 to 1. Its range from minus infinity to infinity, except the 0. And it is an odd function, as you see. It is an odd function, has no periodicity, and its derivative, if you remember, was y dash equals minus 1 over x1 x was x squared minus 1, and modulus x was greater than 1. I remember I give you a very, very important note. Take care, don't multiply both numerator and denominator by minus and you say that these are the same. No, I told you this always positive because x less than 1, and this is always negative because x greater than 1. So maybe in the shape they are similar, but they are different completely. Okay, as you see, any asymptote, any tangent will make an acute angle with the x-axis. An acute angle has its tangent as a positive quantity, while here the tangent to curve will make obtuse angle زاوية منفرجة more than 90, so its tangent will be a negative value, because as you know, for an angle greater than 90, its tangent tan, this angle will be negative. It is in the second quadrant, and in the second quadrant tan is a negative value. Okay, we stated previously that the hyperbolic functions are defined in terms of the exponential 1, or they are dependent on the exponential 1, e to x and e to minus x. If you remember, we stated that, or we defined that sin x equals e to x minus e to minus x divided by 2. Cosine x equals e to x plus e to minus x divided by 2. Tangent x equals sin x over cosine x, which is e to x minus e to minus x divided by 2, and in the denominator e to x plus e to minus x divided by 2, the 2 cancels each other. Cotangent x is defined as 1 over tangent, so it is e to x plus e to minus x divided by e to x minus e to minus x, and sec x is divided as 1 over cosine x, which is 2 over e to x plus e to minus x, and finally cosec x, which is 1 over sin x, is defined as 2 over e to x minus e to minus x. Okay, that we stated before in the first lecture of the hyperbolic function. Someone may wonder, if sine, cosine, tanh, cotang are dependent on the e to x and e to minus x, and e to x is the inverse of ln. E to x, the inverse, if y equals e to x, this is f of x. Hence, the inverse function x equals f minus 1 y means ln y. If you remember, e to x and ln are the inverse of each other. So, if sine, cosine, tanh, cotang, sech, cosech are dependent on e, what about their inverse? Sine, cosine, tanh, cotang, sech, cosech has the inverse sine minus 1, cosine minus 1, tanh minus 1, cotang minus 1, sech minus 1, cosech minus 1. And e has the inverse ln. Is the inverse hyperbolic functions are in this case dependent on ln? E has its inverse as ln. Okay? The function has its inverse as ln. Okay? Now, sine, cosine, tanh, cotang, sech, cosech, and so on are related to e, and it's reciprocal e to 1 over e to x or e to minus x. Now, are sine minus 1, cosine minus 1, tanh minus 1, and so on are related to ln? Yes. This is the fact which we'll discuss in this lecture, inshallah ta'ala. How come? Let us show this relation. Now we'll discuss how the inverse function of the hyperbolic functions are related to the logarithmic function, or how can the inverse hyperbolic function are expressed in logarithmic form, as the hyperbolic function sine, cosine, and so on are defined and expressed in the exponential function, and the ln is the inverse of the exponential function. So the inverse of the hyperbolic will be expressed in the inverse of e, which is the logarithmic function. So we are now discussing how to derive the logarithmic form of the inverse hyperbolic functions. Let us do this together. As you know, y equals sine minus 1x means x equals sine y, right? Which is e to y minus e to minus y divided by 2. Okay. Simplify. Multiply both sides by 2. So 2x equals e to y minus e to minus y. Multiply both sides by e to y. Both sides. Okay. So we have 2x times e to y equals e to 2y minus 1. Why? E to y times e to minus y. E to y times e to minus y means e to y minus y minus e to 0, which is 1. Okay? Move all the quantities in one side. So e to y minus 2x e to y minus 1 equals 0. E to 2y can be expressed as e to y squared minus x e to y minus 1 equals 0. Right? This is a quadratic equation, معادلة من الدرجة الثانية in e to y. Like we said before, some quantity squared plus b is that quantity plus c. If you remember, when we cannot factorize, as in such a case, we have what we call quadratic formula. This quantity equals minus b plus or minus b squared minus 4ac divided by 2a. As you see, a equals 1. As you see, a equals 1. As you see, b equals minus 2x. As you see, c equals minus 1. Therefore, that quantity which is now replaced will be replaced by e to y equals minus b minus minus is 2x plus or minus b squared 4x squared minus 4ac. A is 1, c is minus 1, minus 4, which will be 4, divided by 2a, which is 2. Take care of this quantity. We can take 4 as a common factor, which will be out of the root by equals 2. So we can divide all by 2 to have x plus or minus x squared plus 1. Stop here. We have two roots as you see. Actually, one will be rejected and the other will be accepted. Why? As you know, x squared plus 1 greater than x squared. Right? So, the root of two sides, root x squared plus 1, is greater than x. Right? Right. So, x minus root x squared minus plus 1 will be negative. Why? Because x less than the root. So, x less than the root, this will be a negative value. But as you know, and as I warned you many times, e is a positive function. It is completely over the horizontal axis. All the values of the exponential function are positive. Either e to x or e to minus x. The same. Both are positive functions. Okay, both are positive functions. So now, in such a case, if we accept the minus sign, this would be negative, and this is contradicting with يتعارض with the value of e, which is a positive function. So we reject the minus sign and accept only the positive sign. So we have to write. Only the positive value. So we accept e to y as e to y equals e to y. We'll accept only the positive value, x plus square root of x squared plus 1 equals x plus square root of x squared plus 1. This is e to y, hence y equals ln x plus root x squared plus 1. But y as you see, y is shine minus 1. So, shine minus 1 x equals ln x. That's what we call the logarithmic function form of the inverse hyperbolic function shine minus 1. This is what we are looking for. Okay? Now, someone may wonder, we already obtained is this y dash as 1 over 1 plus x squared. If we differentiate this with respect to x, we will obtain the same form. Yes. How come? Let us try. Since y equals ln x plus x squared plus 1 under the root, so y dash equals the derivative of ln is 1 over times the derivative of its argument, which is 1 plus 1 over 2 root times the derivative of 1 on the root, what is under the root, which is 2x. Simplify please, 2 with 2, so and x plus root x squared plus 1 divided by the root over x plus root x squared plus 1. This cancels this, and the remaining is which we have already had before. Okay, exactly as before. Okay. Also we have y equals cosec minus 1x, means x equals cosec y. Okay, but cosec y is 1 over sin y. 1 over sin y. Sin y is e to y minus e to minus y divided 2, here is 2. as you cross product طرفين في وسطين، cross product طرفين في وسطين، وobtain 2 equals x e to y minus x e to minus y. Multiply both sides by e to y. Okay, this will be 2 e to y, this will be x e to 2y, this will be x only in one side, so x e to 2y minus 2 e to y minus x equals 0. Okay, which is x e to y all squared, okay, minus 2 e to y minus x. This is a quadratic formula in e to y, as we discussed a few seconds ago. A b plus c equals 0. Okay, use the quadratic formula we used before. So e to y equals minus b, which is 2, plus or minus b squared, which is 4, okay, and minus 4ax, a is x, minus 4c, ac, minus 4ac, minus 4, a is x, c is minus x, so x times minus x is minus x squared, and here is minus, so it is x squared, divided by 2a, which is 2x. Simplify, we obtain 1 plus or minus 1 plus x squared divided by x. Similarly, few seconds ago, now I'll rewrite it. E to y equals 1 plus or minus 1 plus x squared divided by x. We will refuse the minus sign. Why? As you know, 1 plus x squared is greater than 1. So root 1 plus x squared is greater than 1. So 1 minus root 1 plus x squared is negative. But e to y is always positive. The exponential function, whatever e to y, e to x, e to z, whatever it is an always a positive function. So we'll use the negative sign. Therefore, e to y equals 1 plus root 1 plus x squared divided by x. Therefore, y equals ln 1 plus root 1 plus x squared. This again, y is cosec minus 1, y is cosec minus 1, y is cosec minus 1, so cosec minus 1 equals this. Therefore, cosec minus 1x equals ln 1 plus square root 1 plus x squared divided by x. This is the logarithmic form of cosec minus 1x. Someone may wonder why you followed sin minus 1 by cosec minus 1. Why didn't directly obtain cosine minus 1? I'll tell you why. Because we can obtain this directly from the definition of sin minus 1. How come? As you know, y equals sin minus 1x means x equals sin y. But sin is 1 over cosec, right? Nice. So cosec y equals 1 over x, the reciprocal of both sides. Okay, therefore y equals cosec minus 1 over x. Oh, very amazing result, very amazing result. نتيجة مدهشة للغاية. ازاي؟ shine minus 1x y shine minus 1 it is the same as this is y. This is shine minus 1x. So shine minus 1x is cosec minus 1 over x. Generally shine minus 1 any quantity means cosec minus 1 over that quantity, or cosec minus 1 any quantity equals shine minus 1 over that quantity. Okay, actually this property is still preserved for the inverse trigonometric functions. What do you mean? Sine minus 1 some quantity equals cosec minus 1 over that quantity. Cosec minus 1 some quantity equals sine minus 1 over that quantity. This property is reserved for the inverse trigonometric function as it is already existing for the hyperbolic, the inverse hyperbolic functions. Okay, so what this, how this will help us? Instead of this lengthy proof for the logarithmic form of cosec minus 1, we already obtained that of shine minus 1. We already obtained that of shine minus 1. To have that of cosec minus 1, replace hx by 1 over x directly. This is the logarithmic form of shine minus 1. Okay, but this shine minus 1 is the same as cosec minus 1 over x. So we obtain the expression for shine minus 1 and replace hx by 1 over x directly. Cosec minus 1 anything is shine minus 1 that thing, but in the reciprocal form. So we already obtained that shine minus 1 equals this. So cosine minus 1x is the same like this, but replace x by 1 over x. Since shine minus 1x equals ln x plus square root 1 plus x squared, okay, therefore cosec minus 1x equals ln the same but replace hx by 1 over x to obtain ln 1 over x plus square root of 1 plus 1 over x squared. Simplify. Ln 1 over x plus 1x squared plus 1 over x squared, which is ln 1 over x divided by x squared plus 1 over x. Simplify, it is ln 1 plus square root x squared plus 1 divided by x, which is the same result we already obtained. This is cosec minus 1, and it is the same here, the same directly. We obtained it, as you see, half a page. So if you keep in mind only that three expressions or logarithmic expression for shine minus 1, cosine minus 1, tangent minus 1, you can directly obtain these of cosec minus 1, sec minus 1, and cotangent minus 1 by replacing hx in shine minus 1, cosine minus 1, tangent minus 1 by 1 over x. Okay? Now let us obtain the logarithmic expression for cosine minus 1, then obtain that of sec minus 1. Okay, okay. Y equals cosine minus 1x. Okay, therefore x equals cosine y, which is e to y plus e to minus y divided 2, or 2x equals e to y plus e to minus y. Multiply both sides by e to y. Same procedure. Okay, so 2x times e to y equals e to 2y plus 1. In one side we have e to y all squared minus 2x e to y plus 1 equals 0. Quadratic form. Some quantity squared, a plus b, that quantity, plus c equals 0. So this quantity is e to y. Therefore e to y equals a, as you see, is 1. b is minus 2x. c is 1. Minus b is 2x. Plus or minus square root b squared, which is 4x squared. Minus 4ac. Minus 4ac. Minus 4. A is 1. C is 1. So it's minus 4. Divided by 2a, which is 2. Simplify. Take 4 outside, which will be 2. So we have x plus or minus x squared minus 1. In such a case, we'll accept both positive and negative sides. Why? Why? Because we have x squared minus 1 is less than x squared. Right? So, taking square root of both sides, root x squared minus 1 is less than x. Okay? So, x minus root x squared minus 1 is positive. And the same sign, if it is plus, it is positive. Since x is greater than the root, so the subtraction from x by x squared minus 1 under the root would be positive. So we can accept both sides. Now this is e to y. We need y. Y, which is cosine minus 1 x equals ln x plus or minus. Okay, let us consider only the positive side for facilitating our calculations. Okay, it doesn't matter to take positive or negative, but only for facility of the operations we'll consider only the positive. But remember, I can accept also the negative side. Okay, okay. Keep this, but in the next operations we'll consider only the positive one. Okay, this is y equals cosine minus 1. So we have already obtained that y equals cosine minus 1x equals ln, that value we have already obtained, this 1 ln x plus root x squared minus 1. Okay, we obtain the derivative of this function as if you remember y dash equals 1 over square root of x squared minus 1. Can we obtain from here? Yes. How come? Let us calculate. As you see, y dash equals the derivative of ln, which is 1 over x plus root x squared minus 1, and multiplied by the derivative of this argument, which is 1 plus 1 over 2 x squared minus 1 times 2x. 2 is 2. Simplify. This is root x squared plus 1 x squared minus 1 plus x divided by square root of x squared minus 1, all divided by x squared minus 1 plus x. Simplify this with this, you obtain finally 1 over, which is the same derivative we have already obtained many days ago. Okay, now for sech minus 1, y equals sech minus 1. What about its logarithmic form? What about its logarithmic form? as we said before, sech minus 1 x is cosine minus 1 over x. So we obtain the logarithm form of cosine minus 1 and replace each x by 1 over x. So this equal ln x plus square root of x squared minus 1, where every x is replaced by 1 more x, which is ln 1 over x plus 1 over x squared minus 1. Okay, simplify this ln 1 over x plus 1 minus x squared x. Take x as a common factor, common denominator, 1 plus root 1 minus x squared divided by x. This is the logarithmic form of y equals sech minus 1. Okay? Someone may wonder, you wrote this depending on one derivation between sine minus 1 and sech minus 1. How can you apply directly for, I told you it is a general expression. No, something not accepting. Okay, let us prove it. No problem. No problem. You know y equals sech minus 1x means x equals sech y, right? But sech y is 1 over cosine y. Therefore, x equals sech y, which is 1 over cosine y. Right? Right. Okay. So, from this expression, cosine y equals 1 over x. Right? Right. So, directly y equals cosine minus 1 over x. But y is sech minus 1x. Y is sech minus 1x. Therefore, sech minus 1x equals cosine minus 1 over x. So we can make use of sech minus for cosine minus 1 to express sech minus 1. How? By replacing every x in the expression of cosine minus 1 by 1 over x instead of x. Okay? No problem. No problem. No problem. Okay? So, a few seconds ago, we said it is ln. If you remember, cosine minus 1, cosine minus 1. If you remember, we said that cosine minus 1 is x ln x plus x squared minus 1, but replace every x by 1 over x as we did a few seconds ago. Okay? No problem. Okay. Now there's still tangent minus 1, cotangent minus 1, no problem. Y equals tangent minus 1x, therefore x equals tangent y. But tangent y is sine over cosine, so x equals sine y over cosine y. Sine y is e to y minus e to minus y divided by e to y plus e to minus y. As you know, divided by 2 cancels each other. Okay? As we did, multiply by e to y over e to y, both in numerator and denominator. Okay? To simplify, we obtain e to 2y minus 1 divided by e to 2y plus 1. So x equals e to 2y minus 1 divide e to 2y plus 1. Cross multiplication طرفين في وسطين. So x times e to 2y plus x equals e to 2y minus 1. Simplify. How? this to the left side and 1 to the right side. So we have x plus 1 equals e to 2y minus x e to 2y. Take e to 2y as a common factor. Therefore, e to 2y times 1 minus x equals 1 plus x. Okay? So finally, e to 2y equals 1 plus x divided by 1 minus x. Therefore, 2y equals ln 1 plus x divided by 1 minus x, or y equals half. But y is tangent minus 1. But y is tangent minus 1. Therefore, tangent minus 1 y, tangent minus 1 x equals half ln 1 plus x divided by 1 minus x. Don't forget modulus x less than 1 as we discussed at the beginning of our lecture. Okay? If you remember, I drew the curve of tangent minus 1 and I show you the domain between minus 1 and 1. Okay? This is tangent minus 1. How do you expect will be that of cotangent minus 1? We'll replace hx by 1 over x. In case of y equals cotangent minus 1x, this will be tangent minus 1x 1 over x. So we replace the expression of tangent minus 1 such that every x is replaced by 1 over x. This will be half ln 1 plus x divided by 1 minus x, but replace x by 1 over x. This will be therefore half ln 1 over x 1 minus 1 over x. Simplify, it will be half ln x plus 1 over x minus 1. This is agree what we already know. Modulus x must be greater than 1 to have a positive argument of the ln. The same like here, we have must have a positive argument of the ln. So as you see, we already know modulus x less than 1, so this will be always positive. Also, we know that for the cotangent minus 1 function, its range, its domain for modulus x greater than 1. It is greater than 1 and less than minus 1. So this will be always positive, as it must be. Okay? Someone still, no, I have some doubt and عندي بعض الشك في هذا الأمر. Don't worry. Everything can be approved as it is a correct thing. As you know, y equals cotangent minus 1x means x equals cotangent y. But cotangent y is 1 over tangent. Okay? So therefore, between this and this, tangent y will be 1 over x. Therefore, y equals tangent minus 1 over x. But y is cotangent minus 1. Therefore, this equals cotangent minus 1x. Or simply cotangent minus 1x equals tangent minus 1 over x. So I have the right to use that expression of tangent minus 1 by replacing every x by 1 over x. In the same way, tangent minus 1 over tangent minus 1 x equals cotangent minus 1 over x. Okay? No problem. Don't worry about it. Okay? Okay. we said a few minutes ago that this important fact is preserved for the inverse trigonometric functions. What do you mean? Sine minus 1 some quantity equals cosec minus 1 over that quantity. Cosine minus 1 some quantity equals sec minus 1 over that quantity. Tan minus 1 some quantity equals cotan minus 1 over that quantity. We can prove it in few seconds. How? Let y equals sine minus 1 x. This means x equals sine y, but sine is 1 over cosec. Therefore, cosec y equals 1 over x, or simply y or equals cosec minus 1 over x. But y is sine. Y is sine. Therefore, sine minus 1x equals cosec minus 1 over x. Vice versa, cosec minus 1x equals sine minus 1 over x. No problem. Okay? Also, y equals cosine minus 1x means x equals cosine y, okay, which is 1 over sec. Right? Therefore, sec y equals 1 over x, from which we obtain y equals sec minus 1 over x. But y is cosine minus 1. Therefore, cosine minus 1x equals sec minus 1 over x. And vice versa, sec minus 1x equals cosine minus 1 over x. Finally, y equals tan minus 1x. We expect to prove that tan minus 1 over x equals cotan minus 1x, and cotan minus 1x equals tan minus 1, and tan minus 1 and tan minus 1x, tan minus 1x equals cotan minus 1 over x. How come? Let us prove this. Y equals tan x means x equals tan y, okay, which is 1 over cotan y. Therefore cotan y equals 1 over x, from which y equals cotan minus 1 over x. But y is tan minus 1. This is tan minus 1 x, as we expected. Okay? Piece of cake. Okay. Now, I remind you by a statement I said in the first lecture of the hyperbolic functions. I told you, inshallah, by the end of studying these functions, I'll tell you why they named it by the name hyperbolic functions. Why? I'll tell you now why they said this. Actually, we studied at the beginning the trigonometric functions الدوال المثلثية. Okay? These functions called circular functions, الدوال الدائرية. These functions are called circular functions. Why? We know the Golding relation between sine squared and cosine squared. We know that sine squared x plus cosine squared x equals 1. You remember this? Okay, okay. Now, if we have a circle like this, okay, of radius A, okay, the coordinates إحداثيات هذه النقطة are X and Y, right? This is some angle, say theta. This is X, this is Y. From this right angle triangle, opposite is Y, adjacent is X, hypotenuse is A. Okay? What are the relations between the coordinates X, Y and the radius of the circle? As you know, X over A is cosine theta. X over A equals cosine theta. Right? And Y over A represents sine theta. From which X equals A cosine and Y equals A sine, right? So any point X and Y are the coordinates of any point on the circle. X and Y are any point coordinates of any إحداثيات any point on the circle. Okay? How these coordinates are represented? They are represented in terms of the radius of the circle and in terms of the trigonometric function sine and cosine. Therefore, we name these functions as circular function. Okay? So any point on a circle can be represented in terms of sine and cosine. Hence, we can name sine, cosine, tan, cotan, sec, cosec, and so on by circular functions. Now, we have, this is a circle. This is a circle. Also, we have many important curves in real life. For example, this is what we call ellipse. قطع ناقص. This is what we call major axis, المحور الأكبر, minor axis. If this is A and this is B, the equation, inshallah you will study this, and we'll prove it for you. The equation of this curve is x squared over A squared plus y squared over B squared equals 1. Actually, the circle is a special case of the ellipse. When A equals B, if A equals B, this is called ellipse. قطع ناقص ellipse. This is called circle. The circle is a special case of the ellipse when the major and the minor axes are the same. A equals B, so it will be A squared, which can be transferred to the other side, and in case of A equals B, we have a circle. Of radius A. So we have x squared plus y squared equals A squared in case of A equals B. Okay. Now we have a circle, we have an ellipse, we have a hyperbola. قطع زائد. قطع زائد. What you mean by hyperbola? Do you I think you watch the TV many times, and it may be in some movie or in some documentary program, you saw a nuclear station, محطة نووية. This nuclear station has what we call cooling towers, أبراج تبريد. You may see one of these towers like this. You remember? Actually, when you take any section of this tower, you obtain a curve like this. This is what we call hyperbola. قطع زائد hyperbola. قطع زائد. Okay, this curve has the equation, as will be proved later for you, x squared over a squared minus y squared over b squared equals 1. In case of ellipse, this is positive, and you call one major and one minor. In case of hyperbola, this is a0, this is minus a0. We call this real axis, this is imaginary axis, whatever. No, it is not now our problem, but I want to learn you how the name of hyperbolic function came. Okay, this is the hyperbola. Okay, in case of circle, we proved a few minutes ago that cosine sine satisfies the equation or the coordinates of any point on the circle. Here, sine and cosine satisfies the coordinates of any point in the hyperbola. How come? As you know, we have the golden rule. Cosine squared minus sine squared equals 1. You remember? For any argument, whatever this argument. You remember? Okay. So we can define any point. We can define any point with that hyperbola by cosine and sine. Here, x, y. This any point on the hyperbola. Okay? If x equals a cosine theta. Remember, theta is not an angle. Theta is an angle in case of sine, cosine, tan, cotan, sec, cosec. But in case of sine, cosine, tan, cotan, sec, cosec, this some number. Y equals b sine theta. But we have the equation of the hyperbola as x squared over a squared minus y squared over b squared equals 1. Now, left hand side, substitute by this. X is a cosine theta all square divided by a square minus y is b sine theta all squared divided by b squared. A squared cancels a squared, b squared cancels b squared, so we have cosine squared minus sine squared. What is this value? It is 1, which is the right hand side. So this function satisfies the coordinates of any point on the hyperbola, so the name hyperbolic functions. By the way, the dish on the in your home, the dish, you remember, you know what is the dish? To the TV, for the satellite, and you see many important programs. If this dish is the dish, if this dish we have a section cross it, we will have a hyperbolic section. The section of your dish in your home, the dish connected to your TV. If you have a cross section of this dish, you will have a hyperbolic graph, or the hyperbolic function x squared of a squared minus y squared b squared equals 1. Similarly as in case of cooling towers in nuclear stations. Okay? As you know, these towers must be very near to some river to have a permanent source of water. Okay. Alhamdulillah, we finished our lecture and finished completely our 28 functions. Inshallah, from the next lectures we will have applications, and actually this means our course is finished. The application are repetition of what we studied. It is not a new thing. No, it is how to use what we already studied in the problems of our real life. How to make a graph, for example, how to expand a function, and so on. Okay, so good luck, best wishes.